This video is about recognizing and identifying local max and mins on the graph, determining what happens to a graph as x approaches a particular value, and using a calculator to find zeros, local mins, and local maxes of the graphs. So there's three important parts of the graphs that we are going to be looking at using the calculator today. The three important parts are zeros. Zeros are where the graph crosses the x-axis. These are also known as our x-intercepts. We have two different types of vertexes there. Remember, we have a local max and a local min. So a local max is the high point in a small area of the graph, and a local min is the low point in a small area of the graph. So the boxes here are to remind you of the steps for later on if you're doing your homework and you get confused on how to find either the vertex or the zeros. So let's start looking at some graphing problems. In number one, we have the function f of x equals x plus 1 times x minus 6. We're going to put that into our calculator. So in y1, we're going to put the equation x plus 1 parentheses x minus 6. And in y2, we're going to put 0 because we're going to need that line later on when we're finding our zeros on the graph. So then we're going to hit graph. Now, notice when I hit graph, I can't really see the whole part of my blue line on there, which is a parabola because it's a U shape. So we're going to go to Window, and I'm going to change this so I have x min is -10, x max is +10. I'm going to change my y min closer to -15 so I can see the whole graph, and my y max is 10. Now when I graph, I can see the whole picture. So first thing I need to do then is I need to sketch a graph. I don't need to worry about that horizontal line for the y equals 0. I'm only worried about my U-shaped parabola graph. Remember, it doesn't need to be perfect. It just needs to have a good idea of what it looked like on our calculator. So the first part of the question then is how many zeros are there? So a zero is where it crosses the x-axis. So in this case, we have two zeros, 1 and 2. So to find our two zeros, we're going to use the intersection function of the calculator like we had before. So we're going to hit second trace, option 5 for intersect. Now, there's a blinking cursor that will show up. We want to move it to each part of the intersection. Don't just hit enter 3 times because every time you do it, the calculator is going to just keep finding whichever one it picks. You need to tell the calculator you want both intersections. So first we're going to go to the one on the left. Once I get kind of close to the one on the left, I can hit enter 3 times. It'll give me my intersection is -1, 0. Then to find the other intersection, we're going to do the second trace 5 again. Now this time the blinking cursor is on the left. We already found that one, so we need to arrow to the right to find our other point. So we're going to arrow all the way to the right until we're closer to that intersection. It might take a couple of arrows to get over there. So once we're finally close enough and we told the calculator, hey, we want the one on the right side, now we can hit enter 3 times. And we get our 0 is at 6, 0. So in this case, how many local maxes are there? So remember, a local max is like a hill or a peak or a hump. We don't have any of those. So in this case, we would say that there are no local maxes. We would just put none. And we don't need to worry about finding any ordered pairs then. The last point is how many local maxes are there? So there's one local min, because there's a low point of our graph. So we need to find that point. So in order to do that, we're going to hit second trace. But this time we want to find the minimum. So we want option 3, which is minimum. Now instead of moving to where the minimum is, we need to tell the calculator, look for the minimum between these 2 points. So we're going to arrow to the left of the minimum. So our blinking cursor needs to be somewhere to the left of our minimum. And we want to make sure it's not kind of close to it. We want to put it kind of far away so we make sure that we are way to the left of that point. So now I'm kind of to the left. And I can hit enter. And I see that I put the little dotted line. It might not do that if your calculator is not a colored one. That's okay. Now we're going to go to the right of that point. We got to make sure that we are way to the right of it so that we don't confuse the calculator to find the lowest point. So I want to keep going so I'm out of that valley part a little bit. And now I know my lowest point is definitely lower than my cursor. And once I get to that point, I'm going to hit enter again, hit enter a third time, and it'll tell me my minimum. Now it says 2.5 and there's a bunch of zeros. The calculator has problems with the pixel, so when there's a lot of zeros, we're going to ignore the zeros. So we're just going to say that our point is at 2.5, comma, negative 12.25. So let's look at another example. Number 2, graph the function f of x equals negative x, parentheses x minus 3 squared. So in y equals, for our y1 equation, we're going to put negative parentheses x minus 3 squared. And we're going to leave the 0 for the y2. So we're going to hit graph. So this time I have an upside down parabola, and it's intersecting the graph only once. So in this case, how many zeros are there? Well, we only see it intersecting the x-axis once, so we're going to say that there is 1 0. Now, when we go to find the 0, we're going to hit second, trace, and we want the intersection. So I want to intersect, I want to move close to that intersection, and I'm going to hit enter 3 times. 1, 2, 3. Now this time, when I go to do that, it gives me my intersection is 3, 0. If it doesn't give you the intersection, it gives you an error, that's okay. Then we're just going to use to find the maximum point instead. So in this case, we see our maximum is touching the x-axis. So if you want, you can find the maximum, or you can already tell that the local maximum is a 0 this time. So we would say we'd have one local max, and that point is also 3, 0. And this time we have no local min. So let's try looking at one more graph. So in number 3, we're going to go to y equals. We're going to clear out the y1 equation. And in this case, we have negative x to the power of 3 plus, oops, plus 4x squared minus 1. We're going to hit graph. So in this case, our graph kind of seems like it's snaking. And in this case, I'm actually going to hit zoom 6 so I can reset my window and see that picture a little bit better. So notice in this case that we have kind of a snaking graph. So it goes up, it crosses, and it goes back up. So in this case, how many zeros are there? Well, it's crossing the x-axis in 3 places, 1, 2, and 3. So we're going to have 3 zeros this time. So to find each 0, we're going to go to second, calc, pick intersect. And because I'm closest to the one on the right, I'm going to start there. So I'm going to go to the right one, enter, enter, enter. And I get the point 0.47, comma 0. Then I'm going to do that again. Second, trace 5. We're going to move to the one that's further to the left now. So in the middle, enter, enter, enter. And this one is negative 0.54 when I round, comma 0. And then we're going to find one more. So second, trace 5 again. And we need to arrow to the left to get to that furthest one away from us. Remember, it doesn't matter what order you find the zeros in. You just need to make sure that you find 3 different coordinates because there's 3 different zeros. So once I get close to that point, I'm going to hit enter 3 times. And I get negative 3.94, comma 0. Then how many local maxes are there? So in this case, we have one peak. So this is going to be our local max. So we have one local max this time. So to find our local max, second calc, this time we want maximum, so option 4. So we're already to the left of the maximum, so we're going to hit enter. Then we move to the right of it. We can hit enter again. Then hit enter a third time. and we get that our maximum with rounding is negative 2.67, comma 8.48. And then looking at the graph, we also have a minimum. So to find our local minimum, we're going to do the same thing, but we're going to pick the minimum option. So second calc option 3 this time because we want the minimum. So we want to be to the left of that point. So once we're to the left of our valley, which we already are, we can hit enter. Then we're going to move so we're to the right of that point. Once we're to the right of the local minimum, we're going to hit enter again. Hit enter a third time when it asks for our guess, and we get the minimum. Now remember, anytime that there's an E, we're going to treat that as a 0 number. So we have 0, comma, negative 1. So the first two functions that we had were called quadratic functions. And a quadratic function is always going to have the highest power or exponent of 2. The last graph that we did was a cubic and it has the highest power of a 3. The highest power or exponent of a function is going to tell us the number of zeros that we can have. So based on the number, the highest exponent, that's how many zeros each function can have. So let's look at some functions and determine the number of zeros it could have. So in the number 4, we have 5x cubed minus 2x. Well, x cubed is the highest exponent of 3, so we could have 3 zeros. Now, we don't always have to have 3 zeros from the graph, but that's the maximum number of times it would be able to cross the x-axis. In number 1, or in number 5, we have 1/4 x plus 5. Remember, not having a number there is like a 1. So the max we'd have is a 1, 0, which makes sense because when we have horizontal or vertical or diagonal lines, they always can only cross the x-axis once. Number 6, the highest exponent here is a 6, so that would be 6 zeros. If we were to graph it, it could cross the x-axis up to 6 times. And the last one, number 7, our highest exponent is 2, so we could have at most 2 zeros or 2 times crossing the x-axis.